Hello mathematicians, today's video is on Objective 106, which is sequences. So our objective is that students will be able to identify and solve sequences. Now there's two types of sequences that we're going to talk about today, but before we talk about that, I want to get some vocabulary out of the way. So if you need to pause the video to copy down the objective, do that now. So first of all, what is a sequence? A sequence is merely a list of numbers. A list of numbers. So for example, you might have 1, 2, 3, 4. That's a sequence. It's a list of numbers. The second word we want to define is a pattern. Okay, a pattern is a predictable list of numbers. A predictable list of numbers. So meaning we have a list of numbers and we might need to predict what is the next number. So for example, if I gave you the list 2, 4, 6, and then blank, think about right now, what would be the next number in that list? If you said 8, you are correct. The next number in that list would be 8. Right. The last thing we want to learn, last term we want to learn is term. Right? And term is a number in a sequence. A number in a sequence. So for example, if you had the numbers 2, 4, 6, 8, 2 would be a term. 4 would be a term. 6 would be a term. 8 would be a term. Any of those are terms in our sequence. We're going to get into some different notes, so if you need to, go ahead and pause the video, copy down any definitions that you need to, write down any questions you have. Okay, so what I'd like you to do is pause the video, and I want you to go ahead between sequence 1 and sequence 2, so these two sequences right here, I want you to see if you can identify what kind of sequence is happening. What is the pattern between sequence 1 and the pattern between sequence 2? Alright, on sequence 1, we should have noticed a pattern of plus 3. So to get from 2 to 5, we add 3. To get from 5 to 8, we add 3, and so forth. On sequence 2, we should have noticed a pattern of times 2. To get from 1 to 2, we times 2. To get from 2 to 4, we times 2. Now, these are each sequences, and each of them are different, but one involves multiplication and one involves addition, and they're different types of sequences. So before we kind of get into how you would solve these sequences and how you would find out what is happening between them, I want to talk about the difference between the two different types of sequences. So we have two different types of sequence. The first is an arithmetic sequence, and that is a sequence that involves addition and subtraction. A sequence that involves addition and subtraction. So we're looking at our two sequences from above. Our first sequence, sequence 1, would have been an arithmetic sequence because it involves addition and subtraction. Okay, that is sometimes referred to as the common difference, because when we find that there's addition and subtraction between two numbers, we can refer to that as a difference. So I'm going to go ahead and write a plus and a minus sign above arithmetic to remind myself that the arithmetic sequence involves addition and subtraction. Our second type of sequence is called a geometric sequence. And geometric sequences are sequences that involve multiplication, and division. Sequences that involve multiplication and division. So if we look back up at our sequences from above, we saw that sequence 2 we were multiplying by 2, so that would have been a geometric sequence. A geometric sequence. Those kind of sequences are sometimes called a common ratio, because the ratio, or what's happening between the numbers, can be described with multiplication and division, and a ratio involves multiplication and division. Okay, and I'm going to go ahead just to remind myself and put a multiplication sign and a division sign above geometric. Alright, if you need to pause the video, go ahead and pause the video to copy anything you need to down. We're going to move on to some examples of how we might find what's happening between sequences. So again, pause the video if you need to. Alright, so now we're going to talk about how you might solve sequences. So our directions say for each problem we need to determine whether a sequence is arithmetic, geometric, or no sequence, and then find the missing terms. We have to do all of that. So I'm going to walk you through how I would solve these types of problems. You might have learned other ways to solve these types of problems, and I'm going to show you a way that I would solve these problems. And I want you to use this method, because it's going to help ensure that we don't make common mistakes and that we also take some smart cuts. So when we're looking at a sequence, the first thing we need to figure out, okay, is this arithmetic or is this geometric? And to begin, just assume it's an arithmetic sequence and test out that theory. Is it actually arithmetic? So the first thing I'm going to do is I'm going to do my second number minus my first number. Second minus first. Doing second minus first tells us, are we adding something or are we subtracting? It actually gives us what the pattern is when we do second minus first. So let's see. Let's go ahead and do that. Let's do 24 minus 48, and I get negative 48. Right? Now, this is a sequence, meaning that something must be happening between the two of them. So I need to check. I can't just check between the first two. I need to check between the next two. So I'm going to do third minus second. And let's see what that is. So 12, third term, minus the second term, 24. That gives me a negative 12. Now I'm looking, and the differences between these, 48 and negative 12, do not match. So I'm seeing that this is not an arithmetic sequence, and I'm going to go ahead and cross that out. This is not an arithmetic sequence. If it's not arithmetic, it's probably geometric, and I need to test for that. So I'm going to go ahead and I'm going to use the same method. Oops, I'm sorry, that should be your first step. First step is we're going to do our second term divided by our first term. And then to check it, we'll do our third term divided by our second term. So let's go ahead and try that. Our second term was 24. Our first term was 48. And that gives us 1/2. Our third term was 12. Our second term was 24, and that gives us 1/2. Now these match, 1/2 and 1/2. That must mean that our sequence is geometric. Now the one thing that's a little bit tricky about geometric is you have to look back up at what you did up here and say, okay, what's going on? Okay? When we found this sequence, we were going to the left. And we found that when we went to the left, it was divide by 1/2. But the numbers we need to fill in are going to the right. So I need you to think, okay, well, what would be the opposite of dividing? That would be multiplying by 1/2. And I want to just show you, and you should always check. Let's just verify that that is our sequence. Let's see, what's 48 times 1/2? It gives us 24. Works. What's 24 times 1/2? It's 12. It works. So our sequence must be times 1/2. So we have a geometric sequence and its pattern is times a half. Let's go ahead and talk about how you'd fill in the numbers. We're just going to take the previous term, so 12, and we're going to multiply it by a half, which gives us 6. So our next term is 6. We'll take that 6 times it by a half, which gives us 3. And then take our last term, 3, times it by a half, and it gives us 1.5. So there we have it. We have filled in our sequence, and we know that it's geometric, and its pattern is times by a half. Okay, I'm going to go ahead and delete this so that I have a little more space to do example 2 for you. So if you need to pause the video so that you can create space, do that now. Alright, so now let's look at example number 2. We're going to do just like we did before, and we're going to assume that it's an arithmetic sequence, and let's see if that works. So the first thing I'm going to do, let's actually use black since that's what we used before, is we're going to do the second number, 4.5, minus the first number, 3.2. So remember that's second minus first. And that gives us a positive 1.3. Let's go and try 5.8, our third number, minus our second number. Remember that's third minus second, and that gives us a positive 1.3. Now I'm looking and these two numbers match. We got positive 1.3 both times. That means that this must be an arithmetic sequence. Now let's double check that that is in fact our pattern and we didn't make a mistake. So let's take our first number, 3.2, and let's add 1.3 and we get 4.5. Let's take our second number, 4.5, and add 1.3 and we get 5.8. We double checked our pattern, it works, so that must be our pattern. So what I'm going to go ahead and do is fill in the rest of my pattern. So I'm going to say, okay, we had 5.8, and I'm going to add 1.3. That's going to give me, go ahead and try that on your own, try that in your calculator. That's going to give me a 7.1. I'm going to do 7.1 plus 1.3. That's going to give me a 8.4. Oops, I forgot to write that in up here. So our next term is 8.4. And then I'm going to do 8.4 plus 1.3, and that's going to give me 9.7. So our last is 9.7. So we've run through two examples. We're just finding the sequence. What I want to do now is go through an example where we're trying to find a next term. Okay? So remember, try arithmetic first. Now in this example, we didn't have to because we found out it was arithmetic, and we forgot to write down it was plus 1.3 every time. But if arithmetic doesn't work, go and try geometric. Alright, we are going to try two to three more examples. And let's look at this one. And I'm going to go ahead and use cups because I can see that there's some stuff going on here. Example 3 says, what is the seventh term of 1, 5, and 25? So what is the seventh term of 1, 5, and 25? Now, right now I'm thinking, okay, seventh term. I just need to write out how many terms I have in the first place because that's going to be a little bit confusing for me. So let's just figure out what we have. We have 1, which is term 1, 5, which is term 2, 25, which is term 3. So I'm going to write out lines, and you should always do this if you're asking for the next term. So this would be term 4, term 5, term 6, term 7. So I know I'm going to have to go 4 terms ahead. So to find this one, we're going to use the same method we did before. First, let's see if it's an arithmetic sequence. So I'm going to say, okay, my second number, 5, minus my first is 4. Now I'm going to try third minus second. So 25 minus 5 is 20. These two numbers do not match, so I know that it's not arithmetic. So think about yourself, what would be my next step? My next step would be, is it geometric? So I'm going to try, I'm going to say, okay, 5 divided by 1 is 5. Oops, and I keep doing that, but that's our first step. Okay, next, let's see. Our third divided by our second, 25 divided by 5 is 5. I got two numbers that match, so I know that this is going to be geometric. And remember, with geometric, we have to think, okay, we were dividing this way, so to go to the left, we're going to divide by 5. But to go to the right, we're going to have to do the opposite, so we're going to have to times by 5. And let's just double check to make sure that's right, because we should always double check before we start to fill in our numbers. So 1 times 5 is 5. That works. Let's try 5 times 5 is 25. That works. So I must be multiplying by 5. I want you to go ahead and pause the video, fill in those last 4 terms, and then press play when you're ready to see if you got them all right. So we should have had 125, and then you should have had 625, 3,125, and then 15,625. We could say that the 7th term is 15,600. Oops, and I don't need a comma there. 625. And our sequence was geometric, and we are multiplying by 5. All right, we're going to talk about one more type of example, and that is an example where you have numbers missing in the middle. So let's just quickly differentiate when you use the methods we just talked about and when you should use this next method I'm going to tell you about. If you look at something like example 1 up here, notice that on example 1 up here, you're given the numbers first. You have 3 numbers first. Or in example 2, you have 3 numbers first. You want to use the method we just talked about. Try arithmetic and then try geometric. If you're given one where you have missing numbers in the middle, then you want to use what I'm about to show you. So before I show you what the method looks like, I'm going to have us write out a little bit of directions. So the first thing I want you to do is I want you to find the difference between the last, in parentheses, minus the first, in parentheses. Second, I want you to count the number of commas or moves, and I'll show you what that means in a second. Count the number of commas or moves. Third, I want you to divide difference divided by commas / moves. And then fourth, I want you to fill in your numbers. Go ahead and pause the video if you need to. Take a little bit of extra time to write things down. Okay, so our first step is that we're going to find the difference between the first and last numbers. You always want to do last minus first, just like we did second minus first, because it's going to give us the right sign on our number and make sure that we know whether you are adding or subtracting. And we're also going to put those numbers inside of parentheses, and that's really important, especially when we get to something like example 6 down here when we have negative numbers. So I'm going to do last, which was 68, so I'm going to put parentheses 68 minus first, so parentheses 11, and that gives me a difference of 57. The next thing I'm going to do is I'm going to count the number of commas. Now you can count the number of commas or you can count the number of moves, and I'm going to show you both ways right now. We have 1, 2, 3 commas. So I'm going to put down for step 2 we have 3 commas, or you can also count the number of moves. You're going to start at the first number, you're going to count that you went 1, 2, 3. So either the number of commas or the number of moves. This third step you're going to take is we're going to take our difference. So our difference was 57, and we're going to divide it by the number of commas or moves, which was 3, and we get positive 19. That 19 is telling us that the difference between each of these terms in this example up here is 19. So let's just double check, and we're going to start with 11, and we're going to say, okay, 11 plus 19, that gives us 30. So our second term is 30. And I'm going to go to the next. 30 plus 19 is 49. That's our third term. Now, one of the most important steps is that we always want to check our last number. So I want you to write a little note for yourself. Always check your last number. So the last thing I should see in your work is I should see you checking, is 49 plus 19, what does that give you? And you should get 68. If you get 68, we did it correctly. You should always check that you have that last number. Alright, I want you to go ahead and pause the video, and I want you to try and see if you can do example 5. Go ahead and press play when you're ready, and I'll kind of work you through the different steps. Alright, so you should have done last minus first. So we should have done first. Our first step should have been 24 minus 72, which gives us negative 48. Next, we should have counted the number of commas or moves. So I had 1, 2, 3, 4 commas, or you could have counted the number of moves. 1, 2, 3, 4. Either way would work. Next, we're going to divide our difference, so negative 48 divided by the number of commas, 4, is going to give us a negative 12. Now that negative 12 is really important because that negative in front of it is telling us that we're going to subtract, and that's why it's important to do last minus first. So I'm going to start up my first number. I'm going to say, okay, 72 minus 12, that gives me 60. So my second term is 60. 60 minus 12, that gives me 48. So my third term is 48. 48 minus 12 gives me 36. So my fourth term is 36. And remember, one of the most important parts is to check your last number. 36 minus 12 gives me 24. That's the last term in my sequence, so I must have done it correctly. Alright, we're going to do one more example problem, and that's example 6. And this is a perfect example of when you have to make sure you're doing first minus last in parentheses. And actually, I didn't use parentheses up here, okay? In that particular example, it didn't matter, but the majority of the time it is going to matter, so we want to make sure that we do that. So, my first step, and I want you to go ahead and pause the video, try example 6, and then come back together and you can see the answer. Alright, so, first thing I should do is first minus last. Using parentheses, I should do negative 21 minus, in parentheses, negative 3. Okay, notice, when we do first minus last, the last is its own number, the first is its own number, and the negative, or the minus sign, is in the middle. Our last number is negative 21. We're going to subtract from that a negative 3. Okay, that gives us a negative 18. Next, I'm going to count the number of commas. 1, 2, 3. Or the number of moves. 1, 2, 3. So we have 3 moves. I'm then going to divide my difference, negative 18, divided by my number of commas, which gives me negative 6. And then I'm going to go ahead and fill them in. So my fourth step, starting with negative 3, and I'm going to say, okay, negative 3 minus 6 gives me a negative 9. So my second term is, I'm going to go ahead and erase this, my second term is negative 9. I'll take my next term, negative 9 minus 6. That's going to give me a negative 15. And then last and most important step, negative 15 minus 6. That gives me a negative 21. It works, so I filled in my sequence correctly. Alright, let's go ahead and do a little bit of practice, and then you'll be done with your video for today. Alright, I want you to try 3 examples on this page. I want you to try practice number 6, practice number 7, and practice number 9. So go ahead and pause those 3 videos. When you're ready, press play to see the answers. Alright, so on practice number 6, you should have gotten that it was in, and I'm going to write A for arithmetic, G for geometric. It was an arithmetic sequence. We were adding 4, so your number should have been 7 and 11. For practice 7, you should have gotten that you were dividing by 3. If you didn't get this, chances are that you went and figured out, oh yes, it's geometric, but you were multiplying by 3. That's why you want to check. 81 divided by 3 gives you 27. You also could have had multiplying by a third. That's fine as well. Dividing by 3 or multiplying by a third. Okay, and our numbers have been 3, 1, and 1/3. And on practice 9, you should have gotten that you were adding a fourth. It's arithmetic. And our numbers should have been 0, 4, and 8. Alright, if you have any questions, go ahead and write them down now. Please make sure that anything you are confused about, you highlight for yourself. Anything that you had a question on, you write down your question and come back to class ready to learn.